Hello and welcome back. This is the last section of chapter 2. We'll be looking at 2.4.3, change of basis matrices. All right, so we're going to take V to be a finite dimensional vector space, and we'll have two different bases for V. How do the coordinate vectors VB1 and VB2 relate? All right, so let's see. Theorem 2.4.3 will give us part of the answer. If I have the basis, B1 is in terms of U, B2 is in terms of W, B2 basis for V. Let P be the n by n matrix. So you're looking at each of the vector in the first basis and writing it in terms of the second basis. So this is the U1 coordinate vector in terms of B2, the U2 coordinate vectors in terms of B2, and so on. Then for any element V in V, if you want to get the coordinate vector in terms of B2 for V, and you already have the coordinate vector in terms of B1 for V, then all you have to do is multiply that coordinate vector by P and you get the second coordinate vector. All right, so we'll have a diagram again. I hope this helps you picture the whole argument. So what we're going to do is we're going to look at the identity map from V to V. We're not going to use the same bases for both V. We're going to use B1 here. So I'm going to have, this is LB1, and we're going to have CB1. And on this side, we'll use LB2 and CB2. And so if I take LB1, the identity, and CB2, then that's going to give me the identity map Euclidenize. All right, so B1, B2. All right, so from what we've done in the previous section, we're going to look at the matrix corresponding to these maps. And if you notice, if we take a V here, let me do it in a different color. I've used purple, so let's use orange. If I take V here and I map it down, I'm going to get the vector of V in B1, right? Then V is going to be mapped to V again here because it's the identity map. And if I go down, I'm going to get the vector of V, the coordinate vector, in terms of B2. All right, and so this map here will send VB1 to VB2. All right, so from the work, previous section, the ID of B1, B2 of VB1 is VB2. And so in terms of matrices, that means if I multiply VB1, that vector, by the matrix corresponding to the identity map, then I'm going to get VB2. All right, so we have what we want. We just need to figure out what this matrix is and show that it's exactly that P that we had above. All right, but we know how to find the ID of B1, B2. You apply the identity map to U1, and you write it in terms of B2. So not B2, Bn, in terms of B2. I'll get it. All right, well, the identity map just sends V to V, doesn't change anything. And so that is going to give me U1, B2, UN, B2. And so yes, that map is exactly P. All right, so by doing what we've done in the previous section, applying it to the identity, then we get a matrix, the matrix of the identity, so that if you multiply it by VB1, you get VB2. Right, so that matrix will be important, and we'll call it the change of basis matrix. The matrix P from is called the change of basis matrix, or the transition matrix from B1 to B2, and we'll denote it as P from B1 to B2. All right, in the next few videos, we'll do examples of finding this matrix and using that matrix.